everyone. I'm going to be going over question number 79 from the Chapter 7 Bingo problems. This problem has to do with this graph that I've poorly drawn here for you all to see, which is a potential energy graph right here. And I'm going to start with part C. There are a whole bunch of parts to this, but part C, I drew this beforehand, so you won't have to watch me draw it on camera. So part C wanted to have graphed the potential energy of this system. And so I've graphed it here, and why I started with C also is because it helps answer part A, because it wants to know if U of X, which is this right here, is symmetric about the x-axis, and it is. You can see that there is the symmetry there. So I'll erase that to give us more room. So that's part C and part A. Now part B wants to know if U equals 0 at x equals 0, what is U at x equals negative 1.5. So the way we do that is energy equals U plus K. We know that the kinetic energy at 0 is going to be about 0.14. We can tell right here. And so we can say that is 0.4, and then from there, and also from our U, we know that this is actually 0 from the previous graph we had. So we get E equals 0.4. So now we can plug in that. So 0.14 equals K plus U. And when we do that, we, at negative 1.5, we know that the kinetic energy is 0. So this equals 0 now. So we get that U is equal to 0.14 at negative 1.5. So there's part B. Now part C we went over with that graph. Now part D wants to know what values of x, if any, is F equal to 0. So F is the force. When is it equal to 0? And that's when the force is, or when the potential energy is either at a maximum or a minimum. And so we know from that previous graph that I erased that that happens at negative 1, 0, and 1. Part E wants to know what range of values between x equals negative 1.5 and x equals 1.5 is F positive, is that force positive, and then when is it negative? Well, we can see when it's positive because if the kinetic energy is going up, we know that that force is positive, right? Something is acting on it and is converting that potential energy into kinetic energy. And so, like right here, so from negative 1.5 to negative 1 is positive. Here, it's dipping, so that's actually going to be negative. That force is negative. Same here, or sorry, this is going to be positive, and then that's negative again. That's it for part E. These parts should go pretty quick. And then part F wants to know, it says release the thing from rest at x equals negative 1.3. What is the largest value of x that it reaches during motion? Largest value of kinetic energy it has during motion. And so we know that x, when it equals negative 1.3, kinetic energy is about, I got it, looking from here, which is a lot better than my drawing, I got it to equal about 0.6 joules. And so we can say and then we know from a previous part that the energy of the system is equal to 0.4 joules. 0.14 joules. When we plug this in, we end up getting, let's see, so that's going to end up equaling negative 0.12 joules. So that's the amount of energy, and it wants to know the largest value of the kinetic energy. And so if we look at the graph, we can see that that happens at about, once again, this graph isn't very good, but at this, we can tell that that happens until about negative 0.55. And so between negative 1.3, negative 0.55 is when the largest value of kinetic energy is during the motion that we talked about. So anyway, that is it for question 79. Thanks for watching. I'll see you in the next one.